Hello dear students, I welcome you to this particular subject Structural Analysis 1. So Structural Analysis 1, you must have heard about Structural Analysis 2 as well. So basic difference is there. Structural Analysis 1 is for the determinate structures, and Structural Analysis 2 mostly it focuses on indeterminate structures. So in this particular chapter, we are going to start with axial force, shear force and bending moment diagrams for the frames. And before that, we are going to cover a few basic terms. What are these definitions and what is the concept of statically determinate structure. So to start with, here, coming to the definitions of axial force. So here, what do you mean by axial force? So we all are aware axial force is nothing but force acting along the axis of the beam. So if this is particular, if we consider it as a beam, if this is particular beam, let's consider it as a simply supported beam. So whatever load acting, because of whatever load acting in this on this beam, it will create some axial force here, some axial force, some vertical force. So axial force, it acts along the axis of the beam. And what is shear force? Shear force, this we have learned in semester 3 in strength of materials. So here shear force is nothing but, so because of this particular load, if you consider, if this particular beam is carrying some loads, then if you consider any section, so the algebraic sum of the vertical forces at any section of a beam to the right or left of the section. So suppose we consider only this part, if you consider only this particular part, so algebraic sum of the vertical forces at any section of a beam to the left or right of the section. So we may consider the left section or right section. So it is known as shear force. Coming to the bending moment. Now, bending moment, it is algebraic sum of the moments of all the forces at any section of a beam. So if we consider moment at about any, suppose we consider moment at this particular section. So we will see what are the loads acting here. So let's consider a fresh diagram. So here in this particular beam, so here some load is acting. So we want to calculate what is the moment at any point. So here the moment, algebraic sum of the moments of all the forces at any section of a beam to the left or right of the section. So moment is nothing but this particular load into perpendicular distance. Load into perpendicular distance, it creates a moment. Then once we get these values, we get shear force, then we get bending moment, then our work is only to plot these values. So when we plot them, then it becomes shear force and bending moment diagram. So when we plot this shear force, then we get shear force diagram. When we plot bending moments, then we get bending moment diagram. So shear force is the one which shows variation of a shear force along the length of the beam, and bending moment is one which shows the variation of bending moment along the length of the beam. So these are the basic definitions. Then in your third semester you must have studied this basics of what is cantilever beam, how it looks. So we know this is a cantilever beam. So cantilever beam is a beam which shows the fixity, right? Cantilever beam is a beam which shows the fixed support. One end is fixed and other end is free. Simply supported beam is a beam where one end is hinged and the other end is roller. Simply supported beam, it shows that one end is hinged and other is roller. Overhanging beam is similar like simply supported beam, but it has a overhanging portion over here. Then there is a fixed beam. So fixed beam is like cantilever beam, but here one end is free. In fixed beam both ends are fixed, so we call it as a fixed beam. Then there comes a continuous beam. So continuous beam, you can see it may be like a simply supported beam, but then there are, it can have more number of supports. Okay, so that is a continuous beam. So these are the types of beams. Now let's move to the types of loads. So we have also studied that a load, a point load which is acting, a particular load, if it is acting at some particular point, so we call it as a point load or concentrated load. Then there is a second type of load, we call it as uniformly distributed load. So this particular load is, if we consider it as W it acts per unit length. Okay, suppose length is in meter, so that is load, it acts per unit length. Okay, and then there is third type of load, it's called as uniformly varying load. So you can see that this load is 0 and it is continuously varying. If you see this line, it is continuously varying. So this is uniformly varying load. There is also a fourth type. So if we see this here, we can have such beam. Okay, and there is possibility that any moment is acting. So a couple may be acting on a beam. So that is a fourth type of load. Then there are combination of beams. We know that this particular cantilever beam which is carrying a uniformly varying load. So this is a uniformly varying load here, and uniformly varying load is here, and this is uniformly distributed load and also carrying a point load. So a beam can carry different types of loads and we have to solve such problems. Okay, coming to next type of combination of loading. So in this a simply supported beam which is carrying uniformly distributed load, then there is a point load and then uniformly varying load. And here different kinds of loads. So here you can see there are 2 point loads acting, there is a uniformly varying load and then uniformly distributed load. And here you can see a simply supported beam where a few more examples, only single point load acting. Okay, only single point load is acting here. Then this particular beam with UDL, W kilonewton per meter. So I said load per unit length, it is acting. Now this uniformly varying load, it can be a triangular load like this also, or different combinations. So we may get variety of load combinations in our study. So here this one example we show simply supported beam with couple acting. Okay, we may get such example. Even in GATE such questions are there. And here simply supported beam with couple acting on it and the UDL also. So combination of loads can be there. Then this is a overhanging beam with combination of loads. So here you can see a uniformly varying load and then point load and UDL and continuous beam with the combination of loadings. Now coming to the types of supports. So here we know we have seen so many beams here. So when we draw a support and if this is a hinge support, okay, so let us consider it as a simply supported beam. Okay, so in this particular support here, it can resist. Okay, this beam, it will become only active, these supports will become active only if it carries some load. Okay, so let us consider this particular beam with these supports. So this particular beam, when it is having one support as hinge support and other is roller support, so this support, it gets activated when there is some load acting. So here on this support there will be some vertical reaction. Okay, so suppose this is a beam, we call it as AB. Let us call this beam as AB. So here this is vertical reaction, so we may write it as RA or VA. Okay, as per our wish, we may write it as RAVA or AY, anything. And here this particular support, roller support, it can resist vertical reaction, so we may call it as RB. So here hinge support, so this particular support, it is capable to resist two types of load, that is horizontal load and vertical load. Okay, so this particular type of hinge support, it is capable to resist vertical reaction and horizontal reaction, whereas roller support, it is capable to resist a vertical reaction only. Okay, so we write always in roller support one reaction we show. Now there is one more support what we study, and that is fixed support. Okay, so this is a fixed support. So fixed support, it is capable to carry a vertical reaction. So you may write it, let us call it as RA. Okay, suppose this is a support A here, let us name is A, so this is RA. Then there is a horizontal reaction, let us call it as HA, horizontal reaction. And it can also resist a moment, it can resist a, it can, suppose this is a cantilever beam, if some load is acting, so it may create a moment over here. So fixed end supports, it has three reactions. Roller support, it has one reaction, and hinge support, it has two reactions. Okay, so these are the very basic and important things one should remember. Now what do you mean by statically determinate beams? Civil engineering is all about equilibrium equations. You must have heard equilibrium equations. Okay, if our structure is not in equilibrium, it is going to get collapsed. This is the basic. So these equilibrium equations are the core of engineering, mechanics, and then strength of materials, and it comes to whole of civil engineering. Okay, so for statically determinate beams, what do you mean by determinate? Okay, so when, if we consider any particular beam, okay, so if we consider any particular beam, let us consider a simply supported beam. So here this particular beam is in 2D. Okay, so there are two things, a structure can be in 2D or a structure can be in 3D. So when we consider 2D, okay, so when we consider 2D, so for 2D cases, when above beam, when we can solve this beam with three equilibrium equations. Okay, when we can solve this beam with three equilibrium equations, what is that? That is summation of forces in x direction is equal to 0, summation of forces in y direction is equal to 0, and summation of moments is equal to 0. So when above beam, okay, when any structure we can solve only using these three equations, then it is called as statically determinate beams. Okay, when we use and we satisfy this particular structure with only these three equilibrium equations, then we call it as statically determinate beams, and that is in for 2D. Okay, now similarly, if we have 3D, if we have structure in 3D, then we need to satisfy, okay, if our structure is in 3D, then we need to satisfy forces. Okay, summation of forces in x direction is equal to 0, then summation of forces in y direction is equal to 0, and then summation of forces in z direction is equal to 0, and also we need to see that summation of moment in x direction is equal to 0, summation of moments in y direction is equal to 0, and summation of moment in z direction is equal to 0. So we need to satisfy this 1 2 3 4 5 6 total 6 equations. Okay, then we can analyze this structure. So this is the statically determinate beam. Okay, so to start with, we can consider a structure. So here let us consider a beam. So for this particular beam, when we have to calculate reactions, so let us call it as beam A and B. So for above beam, let us calculate reactions first. So summation of forces in x direction is equal to 0. Summation of forces in y direction is equal to 0, and summation of moment equals to 0. Okay. So we are going to solve this particular question. So here, suppose this particular beam is loaded with 10 kilonewton per meter load. Okay, and let us consider that this load is this beam is having span of 5 meter. Okay, now summation of forces in x direction. What are the forces in x direction? We can see there are no forces at all, so this is in slipping mode. Summation of forces in x direction is 0. Then coming to summation of forces in y direction is 0. So what is that? We can see the forces in vertical directions. Okay, so we can see here that this particular beam is having here support reaction Ra and here support reaction Rb. Okay, so we can write here equation Ra plus Rb. Okay, so this is going upward, so it is positive, and the UDL which is acting over here, so we can write here 10 into 5, because it is UDL load, it will become 50 kilonewton meter. Okay, so our first equation becomes Ra plus Rb is equal to 50 kilonewton meter. Okay, so this becomes our equation number 1. Now there is, so we have used summation of forces in y direction. Okay, so we have used first equation. Now let's move to summation of moment about any one support A. Okay, so let us say A, so it is 0. So how we are going to write? We are going to write Rb into 5. Okay, as it is moving in anti-clockwise, so let us assume that uh, let us assume our direction clockwise is positive. Okay, and for the forces, upward is positive and downward is negative. So here clockwise is positive, so Rb into 5, so it will become minus 5, then plus Ra into then we have to consider UDL, that is 10 into 5 into half of the load. Okay, 2.5 is equal to 0. So we will get Rb is equal to 50 into 2.5 by 5. So we will get 25 kilonewton as an answer. Okay. So Ra equals to Rb will be equals to, what is our answer? Ra equals to Rb will be 25 kilonewton. So that is our answer. So for this particular statically determinate beam, we have used summation, these two equations, summation of forces in y direction and summation of forces in forces about that moment. Okay, so this completes our basic of statically determinate beams. Okay, hope you have understood this lecture. Thank you very much.